Section F3 and 2.1, lines and zeros. First, we're going to talk about the slope formula. And the slope formula is usually going to be represented by the letter M, and this is going to be a numerical measure. It's a number that measures the steepness of a line. And we're going to calculate the slope of a line if you have 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. Given this idea first that m is really going to be the rise over the run, which is really the change in y over the change in x, which mathematically is going to be y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So now on the coordinate plane, we want to plot the lines with the given points and determine and interpret their slope. So let's start with L1. Now since we're already going to plot the lines, we can just count the rise and the run. But if you would rather use the calculation technique from the formula we just received, you can use that as well. This is entirely up to you. But 2, negative 1 is the ordered pair right here. And let's find that other point, 4, 3. So 4, 3 is right here. Then I have this line. And now I need to count how far did it take to get from this first point to the second point. So we go up 1, 2, 3, 4. So 4 over, rise over the run, 4 and then right 2, so that's 4 over 2. That is, this will reduce to 2 over 1, which is really the slope being 2. So the slope here is 2, and there's a couple of ways to interpret it. For every 4 you move up, you have to go right 2. For every 2 you go up, you have to go right 1. That's the same thing as just 2. That's our slope. L2, let's start with 2, negative 1. So we're starting at that same point there. Negative 1, 4, left 1, and up 4. 1, 2, 3, 4. Okay. Well, let's connect those dots. Looks like this. So now, going from our first point, 2, negative 1, to our second point, negative 1, 4, let's see how to get there. Well, what happens? You can go up 1, 2, 3, 4, 5. So we go up 5. And then we went left 1, 2, 3. But because we went left, it needs to be negative. So understand that anytime you have to go down, that would indicate a negative. And anytime you have to go left, that would indicate a negative. So 5, negative 3. Now, for the record, you could have counted it the other way. That is, I could have started at the point negative 1, 4 and went 1, 2, 3 to the right, 3 to the right, and then you could have gone down 1, 2, 3, 4, 5, but because we went down, it needs to be negative. Well, this is either 5 over negative 3, negative 5 over 3, or if you just want to write the fraction as negative out front with a 5 over the 3, that's perfectly fine. Realize that these are just different ways to write a fraction, and in terms of our slope, it just changes the idea if you decide to go up then left, or down then right. It's your choice. Let's try this L3. We start again at 2, negative 1, and then we need to get to the point 2, 5. So 2, 5 is right here. And if I draw that line, looks like this. So now let's think about our slope. Well, to get from that first point to the second point, I went up a total of 6 marks, right? 6 tick marks. So that's going to be up 6. Well, how far do I go left or right? We go nowhere. We go 0. Well, this is 6 divided by the number 0. But anytime we're talking about division, there's one thing we can't do, and that's divide by 0. And the reason we can't divide by 0 is because no matter what definition we give that thing, it doesn't actually work for our system of numbers. And so we're really going to call this thing undefined because it just doesn't have a definition. L4, we start again with 2, negative 1. Then we go 8, negative 1. Then we connect our dots. Looks like this. Well, let's define our slope. M is going to be equal to the rise. Well, how much up and down do we go? We go none up and down. Well, how far did I go right to get from here to here? Well, I went a total of 1, 2, 3, 4, 5. And so 0 over 5. But 0 divided by 5 is just 0, and so this is a 0 slope. And so just something to notice, vertical lines will always have an undefined slope. Horizontal lines will always have a zero slope. And if your function is increasing from left to right, it has a positive slope, like our purple line. And if it's decreasing from left to right, it has a negative slope, like our blue line does. If a line slants up from left to right, that is, the change in y and the change in x have the same sign, the line is going to have a positive slope. If the line slants down from left to right, that is, the change in x and the change in y have opposite signs, then we have a negative slope. If a line is horizontal, that is, we will have a slope of 0, and if a line is vertical, then we will have an undefined slope because we can't divide by 0. To write the equation of a line, you're going to need two pieces of information. Now, here you can have the point on a line and the slope of a line, but there's two other pieces of information you can have, and that is you could have 2 points on the line, because if you have 2 points on a line, you can always find the slope. So as long as you have either a point on the line and the slope of a line, or 2 points on a line, you can always find the equation of the line. Now, the way we do this is a couple ways, but first let's talk about point-slope form. That is, if I have a point, x1, y1, that's the one that's defined, and m is the slope, then you get y minus y1 is equal to m times x minus x1. Now, if ever you forget this, the truth is this is really coming from our slope form. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then if you solve this thing, well, solve it for y in such a way, you can multiply both sides by x sub 2 minus x sub 1, and you're going to get the form that we have below, y minus y sub 1 is equal to m times x minus x sub 1. The other type that's very useful is slope-intercept form. That is, m is going to be the slope, and b is going to be the y-intercept from the y-intercept being 0b. And you can do this one as y equals mx plus b. The third form of a line, this is usually going to be less useful for most of us, and be a little bit careful because some books are a little picky and you might need the leading coefficient to be positive. But in general, this general form or standard form of the equation of a line, it just means that all your x and y stuff is on one side and your constant is on the other side by itself. So it's ax plus by equals c, but specifically a, b, and c must be integers. And so for an integer, what does that mean? An integer is just a whole number that's positive or negative, so we just need to make sure that we have whole numbers. And so if you have a fraction, you have to make that fraction a whole number by multiplying the entire equation by the LCD. When considering vertical and horizontal lines, these equations that we just discussed won't necessarily apply as needed. You'll have to watch out because a vertical line is always going to be of the form x equals a number, and a horizontal line, since its slope is 0, is always going to be of the form y equals a number. We want to find the equation for a line that has a slope of -6 and a y-intercept of -2. Well, if I'm given the y-intercept and I'm given a slope, my first thought is slope-intercept form. Do you see what I did there? We're not very interesting. The name of the equation is what you need to use the equation. Y equals mx plus b, where m is the slope and b is the y-intercept. So we then have y is equal to the slope, m is -6, and our y-intercept b is -2, so this is y equals -6x plus -2, which is really -2. And so that's the equation of the line that has a y-intercept of -2 and a slope of -6. Now we want to find the equation for a line that has a slope of 1/3 and contains the point 1, -1. So this one, we don't get the y-intercept. We get a point, we get a slope. We probably want to use point-slope form. Y minus y1 is equal to m times x minus x1. And so specifically, my m is 1/3, and this is x1, y1 right there. And so, using point-slope form, I can get this as y minus -1 is equal to 1/3 times x minus 1. but that's going to simplify. So technically it's a perfectly good equation, but notice that we need to put this in general form or standard form. Remember, that is ax plus by equals c, where a, b, and c are what we call integers. Sometimes the symbol for integers is a double script z, and this symbol right here is a lowercase epsilon, which really says a, b, and c are in the integers. We need to get this to this general form, but to do that, all I really need to do is simplify as much as possible and then get the letters on one side. So this is really going to be y plus 1 is equal to 1/3 x minus 1/3 using the distributive property. Now I'm just going to put this all on this bottom line. Y plus 1 is equal to 1/3 x minus 1/3. I need the constants on the right hand side and the letter stuff on the left hand side. So I'm going to subtract 1, subtract 1. If I'm going to subtract 1, I need to put this in fraction form. That is negative 1/3 minus 1, but 1 in disguise here is going to be 3 over 3. And so negative 1/3 minus 3/3 is really negative 4/3. So I've got y is equal to 1/3 x minus 4/3. Then I need to move the x stuff over. So I'm going to subtract 1/3 x, subtract 1/3 x. Now I've got negative 1/3 x plus y is equal to negative 4/3. Now remember what I said earlier about a, b, and c have to be integers? Negative 1/3 is a fraction, not an integer. Technically it's called a rational number. Negative 4/3 is a rational number, not an integer. So I need to multiply everything I see by the least common denominator, the LCD. The LCD here between all the fractions is 3. So multiply everything by 3. We can do this because it's an equation. Now use the distributive property. 3 times negative 1/3 x is going to be negative 1x. 3 times y is 3y. 3 times negative 4/3 is negative 4. And this is standard or general form. Now, something I mentioned earlier, sometimes some books are picky about the leading coefficient being positive or negative. And so if for some reason somebody goes, wait, that's not standard form, well, you could say, well, maybe what you really want is a positive out front. And if that's the case, multiply both sides by negative. And if you multiply both sides by negative 1, negative 1 times negative x is positive x. Negative 1 times 3y is negative 3y. And negative times negative 4 is equal to 4. Understand that these two are both equally correct depending upon the textbook that you see. But general form or standard form of a line just means ax plus by equals c, where a, b, and c is an integer. Now we want to find the equation for a line that contains the points negative 2, 1 and 7, 4 in point slope form. So if we want point slope form, that is y minus y sub 1 is equal to m times x minus x sub 1. This is the situation where we aren't given the slope, but we can always find the slope. M is equal to the rise over the run, that is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we have 4 minus 1 divided by 7 minus minus 2. 4 minus 1 gives us positive 3. 7 minus minus 2 is really 7 plus 2. 7 plus 2 is 9. And 3/9 is 1/3. Now we need it in point slope form. So we already have point slope form written above. Now I just need to pick a point. Well, if you ask the question, which point should I choose? Choose whichever one you like better. Usually I choose the point that I think the arithmetic is easier to deal with. And so I'm going to pick the point negative 2, 1 just because both of those values are smaller. And so that is y minus 1 is equal to 1/3 x minus minus 2. And the deal is that if I'm asked to give it in point slope form, technically this is correct. Now they may want you to simplify a little bit. If they want it in point slope form, y minus 1 is equal to 1/3 times x plus 2. But either way, we have found a good equation, and we found it in point-slope form. Now we want to find the equation for a line that contains the point 3, -5, and has a slope that is undefined in slope-intercept form or general form. So what does it mean to have an undefined slope? Well, remember that undefined means divide by 0. And if you can't remember everything, remember that slope is rise over run. And if the bottom is 0, that means the run is 0. That is, the left and right change is 0. If it doesn't change left and right, then this line is vertical. And so the moment I see undefined in slope, that means we have a vertical line. Now specifically, it has to pass through the point 3, -5. But if it passes through the point 3, -5 and it's vertical, it's always going to pass through the exact same x values. It's always going to pass through 3. And since that's the case, this is going to be of the form x is equal to 3. Now it's said to put it in slope-intercept form or general form. And the truth is this one, having an undefined slope, the slope-intercept form doesn't exist. There is no y equals form for vertical lines. But general form, we have it. And if they really asked what a, b, and c were for any reason, this could be x plus 0 times y is equal to 3. That is in general form, but of course we don't write it, so x equals 3 is the general form. Two lines are said to be parallel if and only if they never intersect. That's what we mean by parallel. They never ever touch. Now, there's another way to interpret what we mean by parallel considering the slopes. And so that is, since they'll never ever touch, that means they have to change at the exact same rate all the time. And so two lines being parallel also means that the slope has to be the same. You could also say that the slope has to be the same and their y-intercepts have to be different. Now the reason is that if we define parallel lines to be two lines that never intersect, if they're ever the same line, even though they have the same slope, well, they can't be parallel. Two lines are said to be perpendicular if and only if they intersect at right angles. And so very specifically, for two things to be perpendicular, they must have a right angle here. When we talk about slopes, there's another interesting way to consider perpendicular slopes, and that is if you multiply the two numbers together, the two slopes together, you're always going to get -1. This also is the same thing as saying that the two lines have opposite reciprocal slopes, or the negative reciprocal. So that is, you flip the slope over, the fraction form, and change the sign. So notice that this one has a slope of -1/2. Well, if you take -1/2 and you flip it, you reciprocate it, and then you change the sign, that's going to be +2/1, which is really +2. Now, the other thing we have to watch out for is that because perpendicular lines only have to intersect at a right angle, then lines are also perpendicular if one's vertical and the other is horizontal. So it doesn't necessarily work just to consider slope. Also remember that perpendicular lines occur if one is vertical and one is horizontal. Now we want to find the equation for a line that is parallel to 1/6y equal to x and contains the point 4, -2 in slope-intercept form. Alright, so slope-intercept form, we know that our answer needs to be y equals sum m times x plus b. Since we're given this first one, 1/6y is equal to x, be careful. If I want to find the slope in this line for 1/6y equals x, understand slope-intercept form gives you the slope for free. So let's put it slope-intercept form. That is, solve it for y so that it is y equals. So divide by 1/6. Divide by 1/6. If you recall, division by a fraction is the same thing as multiplying by the reciprocal, so that's y is equal to x times 6/1, which is really 6x. Alright, so that means that the slope we want is 6. Now that we have the slope being 6, and we know that the point 4, -2 is on this line that needs to be, once again, parallel, we know that we need the exact same slope, that's 6, and we have the point 4, -2. So that's going to be y minus y1 is equal to m times x minus x1 using point slope form. That is y minus -2 is equal to 6 times x minus 4, and we want to get this into slope-intercept form, so now I need to solve this equation for y. That is y plus 2 is equal to 6 times x minus 24 minus 2 minus 2. Y is equal to 6x minus 26. Now we want to find the equation for a line that is perpendicular to 3x plus y is equal to 17 and contains the point 6, negative 2 in slope-intercept form. So final answer is going to be y equals mx plus b. We know we're looking for perpendicular. So perpendicular means negative reciprocal slope. So first we need to find the slope of the other line. To find that, let's get it in slope-intercept form. If I've got 3x plus y is equal to 17, I need to solve for y, so minus 3x, y is then equal to negative 3x plus 17. Now the only thing we care about here is this slope, negative 3. But that's not the slope we need the perpendicular slope. So we're going to reciprocate it. So if it's negative 3 over 1, that's the same thing as reciprocated 1/3, and then we change the sign from negative, so we change it to positive. So this is actually the slope we want. M is equal to 1/3. We have the point 6, negative 2, point slope form, y minus y1 is equal to m times x minus x1, and then I've got y minus minus 2 is equal to 1/3 times x minus 6, and then I've got y plus 2 is equal to 1/3 x. 1/3 times negative 6 is negative 2. And then because we want our answer in slope-intercept form, let's solve for y. Minus 2 minus 2, y is equal to 1/3 x minus 4. For the line y equals negative 12, we need to find an equation for a line that is parallel and contains the point 4, negative 9. So what is our slope here? Well, this thing is technically in slope-intercept form. It's y is equal to 0 times x minus 12. The slope here is 0. So for parallel, our slope will be 0. And it's got to contain the point 4, negative 9. And so if we use that, that's going to be y minus negative 9 is equal to 0 times x minus 4. And that's just going to give us y plus 9 is equal to 0. So subtract 9, y is equal to negative 9. Notice that I could have saved myself a lot of time. Y equals negative 12 is a horizontal line. If I want to find that equation, I just need a horizontal line that passes through the 4, negative 9 point. But if it's horizontal, we really just have to look at the y value and say y equals negative 9 to get our parallel line. Well, since we've already discussed that, when we go to perpendicular here, we know that technically we can't play this negative reciprocal game with 0. That's not going to work. But recall that perpendicular to a horizontal line is a vertical line. And vertical lines are always of the form of x equals a number. If it's got to contain the point 4, negative 9, the vertical line that passes through the point 4, negative 9 is x equals 4. Zeros of a graph. Now pay attention very closely to this word. The zeros of a graph or a function are always the x-intercepts. So anytime, and this word's going to keep popping up over and over again in pre-cal. So the zeros of a graph are the x-intercepts. Every time, all the time. So if I have the line 2/3 y is equal to x minus 4, and they ask us to find the slope. Well, to find the slope, it's the easiest thing to do to put it in slope-intercept form. So to do that, I'm going to divide by 2/3, divide by 2/3. This then gives me y is equal to, division by a fraction is the same thing as multiplication by the reciprocal, and so 3/2 times x minus 4. That's then y is equal to 3/2 x, and then 3/2 times negative 4, we'll just write that out. That's minus 4 times 3 is 12 over 2, but 12/2 is 6. So this is y is equal to 3/2 x minus 6. And so now we know that our slope here is the coefficient of x, or 3/2. And because we put this in slope-intercept form, I also get the y-intercept for free, which is -6, right? But don't answer -6. The y-intercept is very specifically the ordered pair 0 and its y-coordinate, -6. Then we want to graph the line, so we could plot the point 0, -6. And then since we have a slope, we can just use the slope to travel to the next point. The rise is 3, the run is 2, that is up 3, 1, 2, 3, and right 2, 1, 2. And if you want, you can keep doing this. 1, 2, 3 up, 1, 2. 1, 2, 3, 1, 2. You can do this as many times as you want, but because if we draw this straight line correctly, we will pass through every one of those points that we were traveling to via the slope. For the line 4x plus 3y equals 12, we want to find the x-intercept. Remember, we find the x-intercept by letting y equal 0. So that is 4x plus 3 times 0 is equal to 12. And so this is 4x is equal to 12. Divide by 4. Divide by 4. X is equal to 3. So then our x-intercept is the ordered pair 3, 0. To find the y-intercept, remember that's where x is equal to 0. That's going to be 4 times 0 plus 3y is equal to 12. But that's 3y is equal to 12. Divide by 3. Divide by 3. Then we get that y is equal to 4. And of course, we need to write that ordered pair. That is the ordered pair 0, 4. And so that is our y-intercept. Now, because we found the x-intercepts and the y-intercepts, we can graph the line using the x-intercepts and the y-intercepts. So 3, 0, 0, 4. There's our x and y-intercepts. Connect the dots. And there we have graphed the line using the intercepts. A truck rental company rents a moving truck for 1 day by charging $28 plus 5 cents per mile driven. We want to write a linear equation that relates the cost C in dollars of renting the truck to the number X of miles driven. So this is going to be some equation. C is equal to something times X plus something else. All right? Or that's our hope. So specifically though, how does this thing change? Well, really, if it starts with a cost of $28, the cost is going to equal $28 plus that 5 cents times each mile. And I claim now we have our linear equation. Well, then they want to know what is the cost of renting the truck for a 126-mile trip. Well, that is, if we make our x 126, what will the cost be? So that's going to be the cost is equal to 28 plus 0.05 times 126, $28 plus a nickel times 126. 126 nickels is $6.30. And then 28 plus 6.3 is 34.3. And since it's money, I'm going to go ahead and give it that decimal there. And so that is $34.30. Now let's play with it the other way around. Let's say the maximum amount of money that you could spend is $250. How far could you take that rental truck and stay within your budget? Well, if we know that the cost is $250, that's going to be equal to the $28 plus the nickel per mile. And so we can just solve for how many miles. So minus 28, that is 222 is equal to 0.05 times x. Then divide by 0.05, divide by 0.05. I get that then 4,440 is our value for x. So we could go to a total of 4,440 miles if that was our budget.